Hi, so we did our project on position-based fluid simulations.
Just to give a little background of why we chose this project, we found a wide use case for fluid simulation in things such as movies, games, and etc. We found a paper by Macklin and Mueller on position-based dynamic solver, which found improvements on smooth particle hydrodynamics. We then implemented this algorithm using C++ and OpenGL, and then also found an open source code from CMU.
This is our initial simulation that only had the gravitational force acting on it with no collision handling.
So this is our final simulation with 300 particles after implementing the full paper.
Our technical approach closely followed the Macklin and Mueller paper. From this paper, we implemented the incompressibility, which helped with keeping a constant density, vorticity confinement, which helped capture more realistic rotation in the particles, and XSPH viscosity, which helped create a more coherent motion in our simulation, and lastly, the tensile instability, which helped solve the overclustering. And here's a side-by-side comparison of two simulations, one with and the other without vorticity confinement and viscosity, the left side being the one without. But you could tell on the left side that the particles move a lot more, and there's also a little weird behavior on the far left side. And some additional extensions that we included are spatial acceleration structures with the KD trees, custom meshes, and also dynamic scenes. Here's an example of the first dynamic scene where you have a gradient on the bottom and then the left wall pushing the particles. And this is the second dynamic scene where you see a particle distribution at the bottom. In this simulation, we demonstrate fluid particles interacting with a sphere.
When reflecting back on our project, we realized we could have done a better job at planning. We didn't know the scope of our proposal, so we resized our initial deliverables. In addition, we pivoted from making the project from scratch and instead used open source code so that we can concentrate more on implementing the actual algorithm. In this project, we learned how to navigate through and parse an academic research paper. This project proved understanding complicated mathematical formulations and being able to translate them into code to be both interesting and difficult.